Alright, so I've got a set of data here for us to do some statistical analysis upon. And this data set is the number of moons that each planet in our solar system has. And I'm including Pluto to make things a little bit easier and just, for, for nostalgia purposes. I know it used to be considered a planet, now it's not. And I just kind of want to go back to good old days where we thought of it as a planet. So we're going to include Pluto. And what we'll do is we'll look at these three different measures of central tendency, or three different measures of the basic shape um, that numbers that a data set will take. And so these three measures of central tendency are mean, which we often call just the average, the median, and the mode. And what I want to show you is how using these three different measures of central tendency um, will give kind of three different perspectives on the same set of data. So all three are valid ways of looking at the data, but they give you different results. So they're different ways of looking at the same set of data. Um, so it might be something like, well, never mind. I was going to think of an analogy, but don't worry about it. So you'll see there's three different ways of looking at the same set of data. And we just want to, when we do statistical analysis, we want to see what is the big picture. What shape are these numbers taking? What do they look like in the big picture? So it's kind of like this swarm of birds. We're not looking at the individual birds. We're looking at, well, what is the way in which they're flying, or which direction are they flying, or how are they swirling around through the sky? So okay, so enough of the metaphors. Let's just do the cold hard calculations on this data set, and then let's look at kind of look at this philosophically. So, all right, let's calculate the mean of this data set. So the mean is the way you find that is you add up all the data points and then you divide it by the number of data points. So we've got let's do this: 0 plus 0 plus 1 plus 2 plus 64 plus 61. We have plus 27 plus 13 plus 3. So we'll sum those up and then we'll divide them by the number of data points. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We're pretending that there's still 9 planets in our solar system. Okay, so let's add those up. 0 plus 0 is 0. We got 1 plus 2 plus 64 plus 61 plus 27 plus 13 plus 3. That's 171. And then we are dividing by 9. So the mean of the number of moons per planet in our solar system would be 19 moons. So mean would be 19 moons. Okay, let's calculate the median, and the median is just the middle value, or the value that divides the lower half of the data from the upper half. So to do that, you need to make sure your data points are in order. So going from the lowest to highest. So they're not quite in order. It's in order for a while, 0, 0, 1, 2, but then it jumps up to 64, and then back down to 61, and then back down to 27. So let's rearrange these, get them in order, and then we can find the median pretty easily. So we've got 0, 0, 0, 1, 2, and then Pluto's moons are next. It's 3, 13, 27. What do we have? 61 and 64. Let's make sure we've got them all there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there's nine planets here on the list. So 9 is a good odd number. That's why I'm including Pluto. So that makes it easy. So there'll be 4 values, 1, 2, 3, 4, before the median, and then 4 values afterward. So 1, 2, 3, 4. So 3 moons is our median. And if you have an even number of data points, so you don't have a nice and easy median like that, you would take the 2 middle points and just get the mean of them, and that would be the median. Okay. Here this is a simple situation. So the 3 is that middle value, so the median is 3 moons. So we're looking at the same data, but different perspective here. The median is 3 moons. The mean is 19 moons. Okay. Let's do our last measure of central tendency, and that's mode. And the mode of a set of data is just the value that occurs most often. So 0 moons occurs twice. There's 2 planets with only with 0 moons, and so that's 0. See, there's says twice. Let me switch colors. Let's just do purple or fuchsia or whatever you call it. Only one planet has 1 moon. Only one planet has 2 moons. Only one planet has 64 moons. So actually, the only number of moons that occurs twice or higher is 0. So 0 is actually the mode of this data set. It's the value that occurs most often. It occurs twice. All the other values only occur once. So the mode would be 0 moons. So mean, median, mode are measures of central tendency, which means if we've just to kind of visualize it, switch colors again. If you've got a bunch of numbers, you know, the measure of central tendency is what value are these things kind of gravitating around or huddling around? And there's there's 3 different ways of doing it. So the mean of this data set is 19 moons, the median is 3 moons, and the mode is 0 moons. So depending on what kind of question you want to ask, you have to choose what kind of measure of central tendency you want to do, because as you can see, you get very different values. If I tell you the mode of this data set is 0 moons, that might give you the idea that moons are very rare in the solar system, depending on how you frame the question. If I tell you the mean of the number of moons per planet in the solar system is 19 moons, you might get the impression that there's a bunch of moons in the solar system, which is true. But then it might surprise you that there's a planet that has 0 moons. In fact, there's 2 planets that have 0 moons. That's 2 out of the 9 planets have 0 moons. So you might say, well, it occurs pretty frequently that a planet has 0 moons. So these are different perspectives on the same set of data. So you have to choose carefully what kind of perspective you want to take, depending on what kind of questions you want to ask.